Hey folks, welcome back to another quick midweek machining video. What I'm going to do here is I'm going to take a brass T and I'm going to make a right angle for an inlet on it when you have a horizontal approach from a fuel tank outlet, for example a pingle or a regular fuel cock, and you have very little height. And I'm going to show you the bike I'm working on. It's that 80KZ 1000 because I want to get that fuel delivery set up to the carburetors a little bit better. I've done this a couple times and it's worked out fabulously. So what I have here is, I think these are 1/4 inch, brass or whatever they are, brass tees. And we're gonna end up cutting this down flush. Just taking it out actually. I'm gonna probably hacksaw it off, facing it real quick, and drilling it and perhaps reaming it. And then we're gonna chuck this up and we're gonna basically do the same and turn it down so we can press that in and maybe run a little bit of solder on it. So essentially it'll be like this when we get done. You'll have an inlet instead of vertical, horizontal. Now I'll show you what I mean where the problem lies on the bike. All right, so we have very little room in here, as you can see. The fuel lines are just dangling in the breeze right now. There are 2 fuel T's on the carbs, so I need to connect one outlet, or I should say one fuel line and a filter to the 2 T's, which is where the brass T comes into play. But if you have the brass T, let me switch over this way. If you have the brass T sticking straight up, okay? When you have it sticking straight up, the fuel line has to come off and go up and then down. And it's very hard to do that without a molded line. So this is why we put another 90-degree joint in there. And that way it's a straight shot, straight from this guy right here to where we're going to put that brass T assembly we're putting together here. And like I said, I've done this a couple times before. It worked really well. So that's the whole point. I know it's really hard to see in here. If I raise this up, maybe it'll be better. But you can see on the other side there, you got a fuel line coming up. It's kind of in the distance past that oil cooler line. And then this one right in front of you. And we're going to run these 2 together. So they're going to come together in the middle. And then when they come together in the middle, there'll be a spout sticking straight out the side, this side, where I can put a straight line right from this pingle outlet, this fuel cock, directly into it. That way we don't have, again, that rise and drop down, because it doesn't work. The line always kinks when you do that. So let's go back over to the lathe and we'll get it done. And the nice thing about this is if you're doing something like this and you need some funky angle, you don't have to put it straight, to the side. In other words, parallel with one or the other. You can put it off at an angle, put it however you want. And we actually may end up doing that because that fuel cock kind of comes off at an angle. So I'll make that decision before I press it in, and then maybe or maybe not solder it. Depends on how the press goes. Usually I just press them together, but we'll figure that out when the time comes. So this is the setup I have, which is kind of, this is very common actually, where somebody puts a chuck in a chuck. This 3-jaw and my 4-jaw is way too big, but this 3-jaw can't hold this piece. And my big 4-jaw is just way too large. So I had this small one, which is a spare one that was with the Atlas 618. This really was garbage. I had replaced this one with an actual working one. After I sold that lathe, I refurbished this one so I could use it in this manner and just pressed in. I bored this out and pressed in a pin, or I should say a boss on the back here, so I can just clamp it in a 3-jaw. And I've used it several times for situations like this. It works very, very well. So that's why that's there, and that's why it is the way it is. Let me get the live center out, because we don't need it, and it keeps stabbing my right hand. I've been working on the railroad all the livelong day. That's enough of that crap. Obviously, I indicated this in. I forgot to mention that before I cut that spigot off. That would be kind of hard to do now. So we'll just put a facing bit in here, a facing tool, and then we'll just face it off real quick and then move on with the next sets of operations. 1000 RPM and hand feed it. Actually, I'm going to do 800 just for safety because of the fixturing. 800 RPM and hand feed it. Come on. Oh, I'm in between gears here. Here we go. A3. So you put it in between gears so you can spin this thing around when you're indicating. There's no neutral. So if you put it in between gears, you can do this. If you have it in a gear, you got to turn the whole gearbox to do that. And if you're in a low gear, forget it. I really wish there was a neutral on this. That'll be fine. And you see got a pretty small hole here because the way the material's set up. We're going to drill straight through it, even if it goes inside the diameter of the bore inside there. Doesn't matter. There's plenty of material on this. And then we'll accommodate for the piece we're going to put in, this guy right here. But I have to calculate out what size hole I want to make that, and then turn this down accordingly. The largest diameter on here is about 295. The smallest diameter, which is probably the one that's more we're more interested in, because naturally we have to go at least to that point or below, is 250. Now let me look at my reamers, because I don't have a whole lot of reamers, but I do have a 249, which is a 1 under 250 reamer, and this is 250, maybe even 251. What I'll do is when I chuck this up is just skim off the high points of this barb. So we're at 250, 251 and have at least that much of a crush. And we'll probably end up having to solder this one because of this. I can't honestly remember what I did with the last ones. Probably the same damn thing, but not 100% sure. So this is going to be a little funky fixturing because we're going to have to use this 4-jaw and just bring one of the jaws way down. But we'll get it when we get to that point. But right now we just got to drill and ream this. So we'll just go, I don't know, 6 or 8 thousandths smaller than that 249 and then run a reamer through. This is a 239 thou drill bit or a letter B drill bit. That'll be fine. We'll take about, well, this is probably going to cut bigger. They always do. And then we'll take the rest out with that 249 reamer. Just hit the bottom. I only do that because if I push this thing in too far and I got to drill through, there's not a bottom there that's mashed up against the, it's, yeah, I don't know, it kind of works better that way for me. I don't know if it makes a hell of a difference at all, but seems to for me. Now we'll run this reamer through. You know what, I better make sure that's the right one. Nothing that says it was put back correctly by the last guy that used it. I wonder who that was. Oh yeah, nothing to it, baby. Let's go ahead and measure that hole for shits and giggles. Of course, this is probably about as accurate as throwing a stone into the Grand Canyon and measuring the clearance. This says it's 248, but this is a small hole to read with these. 247, 248, probably 249. There's no reason the reamer shouldn't run true. Of course, with my luck. Let's break that edge with a Noga tool. So it's pretty simple at this point because we can't do any more with this. Now we gotta fixture this guy up in this chuck, turn one end down, make it fit. What I'm doing here, as you can see, and there's a billion videos on indicating stuff in, I'm spinning the chuck around aimlessly right now because, you know, I don't know why. When you go, and I don't even need it on 0, but for illustration purposes, when you go to the right side of 0, it's plus, and when you go to the left side, it's minus. Right now we're going, well, actually, I should probably put it about in the middle, right? About over here, maybe. To give you a, yeah, there you go. So if we were to split that distance, or difference, that's minus, that's plus, that's minus, that's plus. So we take the plus side, and we loosen the low, which is the opposite side of it, the opposite jaw, because we always quadrant. You know, you go jaw to jaw, jaw to jaw, and then you just tighten up on this, which brings the workpiece away from it. Of course, it didn't work there, did it? What'd I do? Plus, yeah, it should be moving it away. Well, actually, let's just tighten it now. Sometimes you can get it to move pretty well just by tightening it. As we get closer, all we're going to do is tighten jaws. We're not going to even loosen it anymore. Right now we're a little bit plus there. Still, I may have gone too far is what it was because I'm getting close. There we go, much closer. So since we're getting this close, I'm just going to start tightening these jaws instead of loosening the other one. And we can get this thing dialed really close in. So here's a low. All right, so we want to end up moving it up. So we'd actually tighten the other one. So it's just easier to do it this way. We can get it even closer. And there's a high, opposite thing. We want to push it away. So once we get it to this point, we're pretty much within the thou. So we'll just tighten all the other ones up. I'll move it inboard, make sure the thing is straight in the chuck. Of course, it's not going to the moon. It doesn't need to be that perfect, but you know me, I like accuracy. So look at that. That's not bad. We'll leave it at that. It's close enough. 2 thou now. I moved it on that last Titan, but that's okay. Now we'll move it in. Just use the carriage. Slide her on in. And that's further off. So how we deal with this is we got to bump the workpiece around. Tap that down. Then we'll re-indicate the outer part. So essentially what it does is it turns it a little bit. A little too much. All right, let's go ahead and indicate this in, and then we'll just move it out from there, because we may be straight now, it just may be out because of that. So we're plus here. Let's just tighten this one. 2 thou, I think that's pretty good for what we're doing. Let's just go ahead. Let's see, that's low. That's, where are we? That's high. And when you're between 2 jaws like this, you just work between the 2 jaws that you got coming up. So there's that one and that one. That's pretty much 0. This one now is the one that's out. So that's negative. And that is, where was that? This was negative there. So that's positive up there. So we're hot up here, or high rather, hot. Yeah, we'll tighten that one up a little bit. Close enough. All right, move back out. I just like things as accurate as possible. Couple thou, that's fine. We're just gonna run with that now. All right, so we're gonna end up turning this down. I'll cut it off to length. I don't know what length that is yet. And we'll just skim that minor diameter between these barbs. Just skim it, if not even just barely touch it. Put a little dicum on it, that way I can see when I'm getting close to that, and then we'll just run it down. I don't even know if I'll use the feed on this or not. Am I even in feed mode? Yes, I am. I was doing some threading yesterday, so I couldn't remember if I turned it back to the shaft. Aha! I know I'm not there yet because I can see a little of those dicum lines. It's gotta be bigger. Yeah, it's 256, 257. We're gonna leave it big. We don't have to come down to that, because as long as we've got a good portion here, like for example, this inner part there, this is better here to point with. This inner part, for example, I'm not sure if I'll use this one or that one. And to press into the other one that we just did, that's gonna be fine. So we'll just turn this down to the, I don't know, what is it? Probably 253, something like that. Then we'll try slipping it on. Slipping it in, you know? We'll try slipping it in. That's 254. Must have had a chip in there. That's 254 right there. All right, let's just take a really quick skim cut, like light. Spring pass on it. I should probably say at this point, you know, I'm not trying to overcomplicate things. I'm really not. I mean, when do I ever do that? 250 trace right there. This should be 249. It's not going to fit naturally, but we're going to go a little bit further with it until it starts to go. Then we're going to press her on in. So that should be about 249. I really should measure it with a little ball, you know, dealio, but I'm not going to. Let's use the DRO. We'll just move in a thou at a time. This can't leak, you know. Oh, she's wanting to go now. Oh. Yeah, went too far, I guess. So we'll just solder this one. Went a little too far, so that's okay. We'll do the solder deal on it. Either that, or I will use JB Weld and just let it sit overnight. I may actually do that. And I've done it a number of ways. Soldering usually is a little bit better when you have more clearance for the solder to get in there, but we certainly could solder the joint on the top here by just lay some solder in there, and it will capillary in a little bit, especially when it gets hot. It's going to expand a little bit, but that inner one is definitely a little bigger, so we may be okay to push it in. Anyway, that's generally the idea that I'm going with here. Yeah, 251. So if this is a 249 or 250, that's why, or it's probably closer to that. That inner one is definitely a little bit more bigger for some reason. So we're going to be using that inner one. Meanwhile, I'm going to set you aside and I'm going to get the rest of this cut off, figure out exactly how much I want to push in, because I got to leave some space. You know, you got to leave some space above it for the actual hoses to go on. And that should be fine if we push it all the way up to there. I'll show you when we get it to that point. It's a little easier to show you when it's out of the chuck. I've been working. Knock that shit off. Okay, doke. I think I'm going to use a pen torch. We're going to solder it. And what we're going to do is get some flux in here. I love these coffee stirrers, man. I buy them over at Publix, and I tell you what, they work great for doing shit like this. I am not going to change the angle of that. I'm going to put it basically straight out. Because in this application, since I've done it before in the exact same setup, it's worked before, so I'm going to leave it that way. So it's basically straight across. So you can kind of visualize this. The fuel line inlet from the tank is going to come in here. There'll be a filter, hopefully, this side of it, if there's enough room. It comes in here. These go out to the individual fuel tees. There are 2 of them on this RS carb rack, Mikuni RS. I think they're 34 mils if I'm not mistaken. I don't know if this is going to get hot enough. Nope. We'll have a do-over. Do-over! Remember those from school? Do-over! That's too much. All right. Come on, baby. There it goes. Oh, you gotta be kidding. I just freaking smacked it before it. Oh, we gotta do that. Do over. Again. It happens. I'm gonna have a cold solder joint if I don't do it over. That'll be good. There's probably a big blob on the other side. We'll just grind it off. All right, that wasn't so blobby after all. I really would have preferred a press fit, but I screwed up, so we're gonna do it this way. Like I said before, I've done it a number of ways. Press fit, soldering, and with JB Weld, and they've all worked. I've never had one come back. And for anybody out there that's saying, oh, it's gonna crack after it vibrates. Well, this thing's suspended on hose. It's not attached to anything that vibrates. So I wouldn't worry about it. Like, for example, wiring on a frame where people say that it's better to use crimp connectors. In some cases, they're right. The frame is vibrating. The wires are directly connected to that. This is just hanging in the air, basically, off of some hose. It's not going to crack. Polished it up with a little bit of Brasso. Now we're going to test it. You know me, I test everything. So we're going to put the Mighty Vac on. We're going to pull a vacuum and make sure it holds. And if it don't, we put pressure to it, put some soapy water, see where it's leaking. But there's little to no chance that this would ever leak with that kind of solder joint anyway, even after smashing it with the propane bottle. So if you wanted to eliminate all evidence of substandard human intervention on a part like this, for example mine, you'd paint it, you could paint it up. We're just going to leave it the way it is. All right, folks, here's the finished product. I did desolder it, clocked it a little bit more angled because it was too much out of alignment with the outlet in the Pingle fuel cock. So that really is a straight shot, and you can see the fuel filter to the left there. We're hooked up. This would be the carburetor number 1 and 2, and this carburetor 3 and 4 to the right. And there's no leaks. I generally don't use any type of clamping or anything on these barbs. They stay forever. I mean, you need a porta power to get these damn things apart. So I'm real happy with the way it came out, but I wanted to show you what it looks like installed. It is further back behind the oil line because there's just no room up front. Generally speaking, I put that much closer to the carb rack itself, but in this case, you just can't do it. These are inflexible oil cooler lines, and just the way it is. So we got to run around the back here. It works pretty well though because it's easily accessible for inspection, and you can always take a look at it and make sure it's not leaking in the future. But these don't leak. I'm telling you right now, this fuel line, this is good quality fuel line, and these barbs, it doesn't leak. I have it loosely tied up with a wire tie here to the oil line, to the oil cooler line. Mainly what I wanted to do is make sure that it's all downhill. So it's all downhill from the outlet through the fuel filter into this modified T, and then it's downhill down into the carburetors. So anyway, that's it. That's what it looks like. All right, another job done. Let's move on to the next one. As always, thanks for watching. Catch you on the next video.